All right then. To find horizontal asymptotes, well, first of all, just to explain, horizontal asymptotes only matter like way out into the far right and the far left of your graphs. Like the function can do anything it wants to in the middle, but then maybe it approaches some asymptote. So we want to know what it does way, way, way out here. And the way we do that is by taking the limit as x approaches infinity, and then also doing the same thing with the limit as x approaches negative infinity. That's to check for the left side. But first, let's do this. So we'll take the limit of this, and whatever we get, we can say y equals whatever is the horizontal asymptote. That's why you have y equals, because they'll just be horizontal lines. So, if we let this go to infinity, 1 minus 2 to the x. If we let x go to infinity, then this goes to infinity, which means this whole thing goes to infinity, and same with this. So it all goes to infinity. So we have infinity over infinity. So I see, or actually this goes to negative infinity, because if this is infinity, 1 minus infinity is negative infinity. So this actually goes to negative infinity over infinity. So I see that you want to use L'Hopital's rule, but we never had a formula for this. We only had a formula for e to the x. So I'm going to try and do it without limits at infinity, and we'll see what happens. Or sorry, I'm going to try and do it without L'Hopital's rule, and then I'll explain it with L'Hopital's rule. But first, I'm thinking anytime I'm approaching infinity, anytime x is approaching infinity, I think of my limit tricks where maybe I can multiply the top and bottom by the largest power of x, or sorry, 1 over the largest power of x from the denominator. However, I don't really have like powers of x. I don't have exponents on them. X is the exponent. So might as well just multiply by 1 over 2 to the x. This is the same thing as force factoring out 2 to the x. But here we go. So if I multiply by this, I distribute, and I just have 5 over 2 to the x plus 1. And then I also have 1 minus, 1 over 2 to the x minus 1. And then if I take the limit as x approaches infinity here, well, this part goes to 0. Sorry, goes to infinity, so the whole entire fraction goes to 0. That's one of the fundamental limits. If the bottom gets ginormous and the top doesn't, then it goes to 0. So the same thing happens here. So I just get 0 minus 1, that's positive 1, and I get 0 minus 1. Sorry, 0 plus 1, that was a plus. So it gives me positive 1. And then I get 0 minus 1 over here, that's negative 1. So I get y equals negative 1. So my answer could be this, or it could be this, or it could be this. And I think it's E. But that's limit as x approaches positive infinity. So if x approaches negative infinity, this is what's going to happen. So that's negative infinity. That's not from the left side. I'll make it look better. And I'm doing, what is it? 5 plus 2 to the x. And then, what was this? 1 minus 2 to the x. Is that true? Yes. Okay. This is, if you think about it, we're plugging in negatives. So I'm going to take the example like this. I'm going to make an example like this. If I plug in negative 7, no, negative 5. If I plug in negative 5, x equals negative 5. Watch what happens. I have 2 to the negative, and then since I have a negative exponent, I flip it over. 1 over 2 to the positive 5. So really, if this changes my, I guess, expression, if it changes my expression to be a fraction, well, maybe I can do that in the beginning and then put in a positive 5. So watch what happens. So this is going to be the same thing as when I plug in positive 5 to 1 over 2 to the x. So I kind of use this negative before I actually plug it in, and then I take this negative and I put it on the 2 to the x, on the x part, and then it flips it over. Hopefully this makes sense. What I'm trying to say is, instead of plugging in -5, I can flip it over and plug in +5. That's, I guess, a long-winded way of saying that. So instead of going to -infinity, I'm going to flip this over, and then put in +infinity. It's like doing the same thing. Or, actually, this might show it better. If x is approaching -infinity, that would be 5 plus 2 to the negative, not -8, 2 to the negative infinity, that's a heart, negative infinity, and then 1 minus 2 to the negative infinity. So if I have this, oh look, it's negative, okay, flip it over. That's probably the quickest way to explain it, I didn't realize that. So then we have that, and then 1 minus 1 over 2 to the infinity, right? And we're still, well, I guess we're not taking the limits anymore because we put it in there. I guess I shouldn't have written that either. But this goes to infinity, which means the whole thing goes to 0. This goes to infinity, which means the whole thing goes to 0. So I'm just left with +5 over 1. So the answer is E. Beautiful, 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 beautiful. So if you wanted to know the formula for... Actually, I'm not even sure. You should look up derivative of a to the x. I think it's like a to the x times the natural log of a. I think it's the same thing. And so instead of a, you'd have 2. Let's see. I don't know if that would help us or not. In fact, I don't think it does. I don't think it works at all. I think you have to do this. You should try it, because I don't think it's going to work. If you think about it, take the derivative of 5, it goes to nothing. Take the derivative of 2 to the x, and it goes to 2 to the x times ln of x. Well, if I plug infinity into that, this goes to infinity, and this also goes to infinity. So infinity times infinity is infinity, so that doesn't work. So yeah, and then you take the, if you want to do L'Hopital's rule again, you take the derivative of that, but that's just using product rule, and you'll still get either this or this in your product, and neither of those are going to anything that cancels anything else out. So it's not gonna... Oh, wait a minute. This is not true. I was saying silly things. Stuff will cancel, right? Okay, I'm curious. Let's try it. Let's do it in green. So we got 5 plus... You don't have to watch this. I mean, I guess you know that. So I'm not going to write the proper notation or anything. Let's take the derivative. If... I don't even know if my formula is right. So if I have this, it would be over that. Maybe. I hope. I don't know. So then everything does cancel, and I get -1. Sweet. That's what, that's that part. Maybe it's gonna work. And then if I do limit as x approaches -infinity, well, I didn't need L'Hopital's rule on that. Where is it? Yeah, I didn't need L'Hopital's rule. I didn't need any fancy tricks. I just had to realize that I'm plugging in a negative. So, yep, it worked. L'Hopital's rule works. My formula is correct. I'm a genius. Good night.